In this video, we'll be looking at Venn diagrams. A Venn diagram is a visual representation of a sample space. All outcomes in the sample space are in the universal set, and these are contained within a rectangle. Each subset or event is represented using a circle. The overlap of two or more circles represents the intersection between them. Venn diagrams are a useful way to organise information when different categories are presented to you. Here are two examples where the first one has two categories A and B, and the overlap is the intersection between A and B. And the second one has three categories or three events, A, B and C, and you can see that there are four intersection areas. This intersection in yellow represents the intersection of all three events, which is A intersecting B intersecting C. Then this area here is the intersection between A and C. This part is A intersecting B. And finally, that overlap is B intersect C. Venn diagrams are useful when there's a maximum of 3 to 4 subsets, but they are limited after that because you could imagine just how messy these visual representations get when there's more than 3 or 4 circles in the rectangle. Just a quick mention is a Carnot map or a probability table, which can be used as an alternative to a Venn diagram when there are only 2 subsets or events. We're going to explore that in a future video. So we'll do an example where we have after school sport being compulsory in year 7 at a particular school. The school only offers 2 sports, which are swimming and athletics. Out of 120 students, 30 do both swimming and athletics, and in total 54 students swim for the school. So for part A, we want to represent this data in a Venn diagram. So we know straight away that 30 do both swimming and athletics. So the overlap of those two circles is the intersection is going to be 30. Then for the entire circle, which represents swimming, we need 54 students in that. So we've already got 30 in the intersection, so there would be a further 24 students, which we can do 54 take 30 to get 24, that only swim. Now we know that sporting is compulsory, so all the remaining students must do only athletics. Now we need those athletes doing only athletics plus 30 plus 24 to equal 120. So what we're going to do is 120 subtract 30 subtract 24, and all up that's going to be 66. So we know there are 66 students that only do athletics at this school. For part B, we're asked what is the probability that a student selected at random only participates in athletics. So the probability is the number that satisfy that requirement, so 66 students that only do athletics, over the total number that are in our sample space. So we have 66 over 120, which is equal to 11 over 20, which also has an exact decimal of 0.55. So the probability that a student selected at random only participates in athletics is 0.55 or 55%. So after this video, you should be able to know when to select Venn diagrams to represent sample spaces. You should be able to use Venn diagrams to visually represent sample spaces and events. You should be able to use Venn diagrams to determine the probability of events occurring. And finally, you should understand the limitations of a Venn diagram.